All right, my math people, we are back, and this time we're talking about the differentiation rules. And all right, I'm gonna be straight up with you. I'm not going through all of them, okay? I'm gonna touch on the key components. Like the rest of them, you're gonna read somewhere, and you're gonna be like, "Oh, that's it." So I'm gonna touch on these first ones. The first one we're gonna dive on is the power rule. The power rule. All right, so this mess right here is about to blow your mind. All right, for one, because up until this point, we've been going through all of these examples using that long definition, plugging in that f of x plus h and all this blah, 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 blah. When we had all these goodies waiting to be used. So let's say the power rule. The power rule says if you have y equals x to the n, all right? And then we want to find the derivative, all right? We have y prime. That prime tells us first derivative. Power rule says you take the power, bring it down front as a factor. Keep the variable, raise the new power to the n minus 1. What? Let's see what that looks like in real time. Somebody said, give me an example. Example coming up. Example. We have y equals x squared. Simple as example. We want to find y prime. All right. Y prime. Power rule. I look at the variable, I look at the power. Bring the power down front. Boom, multiply it. Now it's a factor. That becomes 2 minus 1. The new power is, so we have 2 times x to the 2 minus 1, and we know that to be 2x. Derivative found without plugging in the first h. You know what? Okay, why ain't we been doing this? Because you had to go through the pain. You had to go through the trenches until you could get to the promise and get to the goods. Somebody help me up. Wait a minute, I'm in the wrong class. So let's get back here. Okay, so let's jump into some more examples. Let's say we have a factor in that example already. Nothing changes. We have y equals 5x to the 6 minus 1. All right. Ooh, we got some smooth stuff happening right here. Let's throw in a quick little note. Throwing in the note over here. Note. The derivative. Y prime. When y is equal to a constant, y prime equals 0. All right, let's make that note make some sense up in this example. So we have y prime equals, applying the power rule, we have that factor right there. Don't worry about that factor. Leave that factor right where it is. Go to your variable. Bring exponent down front. That's raised to the 6 minus 1. Close off that parenthesis. Now we're going to go over to that constant. That constant goes straight to 0. Now what do we have left? We have y prime equal to 5 times 6 is 30. And that's x to the 5th. Somebody talk to me. Keep it rolling. Now let's put some real magical stank on this thing, okay? What if it said, find y double prime? Well, y double prime, you go straight to the problem that you have with y prime right there. So y double prime, I'm going to say 30. Open up that parenthesis, boom. 5 times x, drop that value down by 1. Ooh, Talk to me, somebody. And here's another way that derivative can appear. It might not say prime. It might say, let's go ahead and slide in a note. Note, y prime is the same thing as saying dy dx if your independent variable is x. That's simply saying take derivative of the y function with respect to x. That's all it's saying. All right, let's keep on rolling. All right, let's keep on rolling and see what other things that we have in here. Okay, we have this right here. This right here about to mess you up, okay? Watch this right here. You know how when we had all these other examples in the past, let's say we have, it says find the slope of the equation y equals, let's use that same example up here. Let's say y equal x squared at x equal 5. Why is this, y'all? What we're going to say is the slope, which is y prime, the first derivative is the slope. So we're going to say that's 2x to the first power. And I want to find the slope at x equal 5. So, ooh. Y'all see how I jumped the gun? I got a little bit too excited. That should be 2 times 5 equal 10. So the slope at x equal 5 is 10. Come on, somebody. I know you're mad. And then the problem could say, find this equation of the line. Ooh. So we got the slope. The slope is 10. And the point, the x value is 5. You plug 5 into your equation. So you have 525, and you have a slope of 10. You have y equals 10 times x minus 5 plus 25. The equation of the tangent line, somebody talk to me, is 10x plus 10. Somebody talk to me. I know how you're feeling, because I felt the same way when I was in the shoes you was in right there. I was like, why you ain't show me this in the beginning? All right, so let's move on to the next rule. The next rule that we'll introduce is the product rule. The product rule. All right, so let's say with the product rule, let's say we have the function, because I want to give it to you nice. We have you have two functions. All right, so suppose u and v are both functions. U and v are both functions, right? All right, so, and they're both differentiable. All right, so u and v. So if we want to find the derivative, with respect to x for u times v. Product rule. Here you go, right? All right, you're going to take the first function, times the derivative of the second function plus the second function times the derivative of the first function. So that's u dv plus v du. Hey, I ain't make the rules up. I just abide by them. And I try to make them look good. Okay? So let's go ahead and jump in on an example right quick. Let's say we have an example like example. Let's say we have y equals x squared times x to the fourth minus 21. All right, so first thing I want you to do is notice you have two functions right there. Highlighted in green is your u function. Highlighted in yellow is your v function. All right, so what I'm going to do is just going to write those out. All right, so I'm just going to say u. Oh, no, not with a highlighter. Swing that back. Give me a pen. I'm going to say u equals x squared. And I'm going to say v equals x to the fourth minus 21. All right, so u prime, applying that power rule, 2x. V prime, applying the power rule and the derivative of a constant rule, you have 4x cubed minus 0, so just 4x cubed. So y prime, we have u, that's x squared, times derivative of v, 4x cubed, plus v, and I wrote a v, x to the fourth minus 21 times derivative of u. And that's it, y'all. That's it. So we have 4x to the fifth plus x to the fifth minus 42x. Y prime equal 5x to the fifth minus 42x. All right. Here's some special case stuff that you need to know, okay? Special case stuff that you need to know. Note the derivative of the standard exponential function is equal to itself times the derivative of that exponent there. And that exponent is x. The derivative of x is 1. And so there we go. Keep that in your mind. Keep that in your mind. And that just led me to something else that you need to be aware of. The reason we have derivative of x is 1. Let's just go ahead and point that out. We have y equal x. Y prime. Let's get the exponent that's understood on that x is a 1. So we're going to bring that 1 down front. Then we have x to the 1 minus 1. That equals x to the 0 power. Anything raised to the 0 power other than 0 is equal to 1. All right. So just have that in mind. All right, let's keep it rolling. Let's keep it rolling. The next rule that we shall introduce to the board is the quotient rule. Ooh, no, he didn't go to the quotient rule. Oh, yes, he did. Again, u and v are differentiable functions. Functions of the variable x. The quotient rule says if I want to take the derivative of u divided by v, we go bottom up, baby. All right? We have, starting with the bottom, times the derivative of the top minus the top times the derivative of the bottom all over double bottom. Bottom squared. Double bottom and bottom squared ain't the same thing, so don't confuse that. All over bottom squared. All right. So you have low to high, meaning the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom bottom. All right. Let's put that into an example. You knew we was gonna do it. So here we go. Example. We have y equal 5x minus 7 over 2x squared plus 3x. All right, so we have u in the top right there. We have u it's 5x minus 7. V is 2x squared plus 3x. U prime equals 5. V prime equals 4x plus 3. Don't forget to differentiate all the way through your equation there. So we have y prime equals, what goes on the bottom? Bottom. Bottom. So corny. Gosh. Can't stand when the professor try to make jokes. All right. And then we have bottom times derivative of the top minus the top times derivative of the bottom. And y'all know how to distribute. So you'll go through and you do your whole distributing and roll with that right there. Okay? Now, you really want to get real fancy with your exponents. All right? Those were the three things that I really wanted to introduce. Those, the power rule, the product rule, the quotient rule. Now, you want to be fancy with your exponents from algebra, okay? All right, so your exponent rules can change the game for you. And like you have to know how to manipulate radicals. So let's say we start getting into some weird looking examples. All right, where we're tossing radicals into the equation and excuse me. Let's say we have something like toss in some negative exponents, really change up the game. So we're going to run through a few more examples before we check out. So we have y equals 4x squared minus 15x minus 7x to the negative 3. Before you go jumping into the problem, And I want you to look at that and identify all the components. And look at the rules you're going to need to use. The first term, you need the power rule. Second term, you need the power rule. Third term, you need the power rule. So the whole thing consists of the power rule. So we're going to find dy dx. That's the same thing as y prime. Applying the power rule. We have at 4 right there. Go to the variable times 2x. Minus 15. Go to the variable times 1. Minus 7. Go to the variable. Apply the power rule on the variable. It's negative 3. X to the negative 4. Don't get caught up. Negatives keep decreasing, okay? Simplified, you have 8x minus 15 plus 21 x to the negative 4. All right? Let's really toss in some weird looking stuff. Let's toss in some radicals and some fractional exponents. Hint, radicals and fractional exponents are one and the same. So y equals square root of x plus 16 x squared minus 1. All right. First thing you want to do, again, we're finding the first derivative. First thing you want to do with this is rewrite that radical as a rational exponent. So we have x is equal to the 1/2 power there. So we have x to the 1/2 plus 16 x squared minus 1. Start applying these power rules all the way through. Applying the power rule. You take that 1/2, bring it down front, times that x to the 1/2 minus 1 plus 16 times that 2x. Derivative of a constant. Somebody talk to me. That's right. Somebody said that's 0. Thank you. So your simplified answer is 1/2 x to the negative 1/2 plus 32x. Question, did we start this problem with any negative exponents? No. So don't finish it with negative exponents. Apply those rules of exponents and put that exponent in the denominator since that's a negative exponent. So that would leave us with 1 over 2 square root x plus 32x. Thank you. All right, there's some other things I want you to check out because it can change the game for you. So whenever you look at this example, you would initially look at it and you're like, oh man, that looks like a quotient rule. But I said, hey, you need to be a magician with those exponent rules. You need to be a magician, okay? Over 2x minus 7 over 4x cubed. All right, let's rewrite the problem. We still finding first derivative. Rewrite the problem. Y prime equals 1/2 times x to the negative 1. I told you, become a magician with those power rules. Those laws of exponents. So if you got a variable in the denominator, you can write that variable in the numerator and it's toss a negative exponent on it. I don't need that right there. All this is a rewrite. All I did was rewrite right there, okay? Rewrite. Now, y prime, we have that 1/2 times that negative 1 times the x to the negative 2 minus 7/4 times negative 3 times x to the negative 4. Look at that light work we did. Going through, we have negative 1/2 x to the negative 1/2. I'm sorry, x to the negative 2 plus 21 over 4 x to the negative 4 equals, we have negative 1 over 2x squared plus 21 over 4x squared. That's just really making good use of your exponent rules from algebra. It'll save you a whole lot of time. Trust me. Trust me. All right? And let's see here. You know, that's a good stopping point. So we're going to call it right there. Until next time.